Hi guys, we meet again. Okay, let's proceed with the usage of dot product. We have learned how to calculate dot product before. Now we're going to see one of the use of dot product is to calculate an angle between vectors, right? Please don't make a mistake. The one that we have discussed before on finding direction angle, talking about finding an angle of a vector from an axis x, y, and z. As for this one, we are talking about finding an angle between vectors. Okay. For example, if you look at this, okay, right, currently we have two vectors here, right? Vector v and vector u. By using dot product as one of the component in that calculation, we're able to find out the angle between these two vectors, right? So let's proceed with the discussion. Alright, so the formula is similar to the one that we have discussed before, right? It is just that the adjacent will be the dot product value and the hypotenuse will be the multiplication between the length of A and B, right? So let's try to look at this. Maybe let's try to do exercise 3.8. Alright, okay, exercise 3.8. Given that A and B, these two vectors, they want us to calculate the dot product and also the length, right? So the dot product here is basically just what we discussed before. You should multiply each of the component and sum them together. Okay, so this will give you 18 as the value of the dot product, and then the length. Okay, sorry, for the length, as usual, we are going to sum all of the square. Okay, we have -1 squared plus 2 squared. Okay, and this will give us 14. As for the B, okay, we have 4 squared plus 0 squared plus 3 squared, right, equal to 5. Okay, so now that we have all of this, we can proceed with equation number 2. Find the angles of these vectors. So remember the formula of the angle, okay, theta equal to cos inverse times the dot product, which is 18, over length of A times B. So we have 14 times with 5, which will give us 15.82 degree. Okay, alright, so now let's see where is actually this 15.82. Alright, so let's put the two vector. Alright, you have the first vector here and then the second vector. Alright, so as you can see here, the degree of 15.82 is between the two vector. Alright, so there is 15.82. Okay. So there's some properties that we need to discuss here. Okay, for the dot product, if a dot product A dot B will give the same answer as B dot A, right? And then A multiplied with B and MC, that being sum, is the same as the dot product of AB plus dot product of AC. Okay, just like you expand it out. Okay, A plus B dot C plus D, right, is the same as you do a dot product of AC, AD, BC and BD, also the expansion of this. Then you have K as a scalar, then K times with the dot product value of AB is also equal if you multiply the scalar with A, then do the dot product, or the other way around, where you multiply the scalar with B, then do the dot product with A. Okay. Okay, and if you do a dot product by themselves, you will get 1. Okay. Okay, for number 6 here, please pay attention. These properties might be useful later in the application. If A and B, right, when you do a dot product, is equal to 0, okay, we can say that when you do the dot product, you'll get 0 for this A and B, right? We can say that the location of A and B, right, are orthogonal. In other words, 90 degree. So when you do a dot product, you will get 0. We will assume that A and B is in a 90 degree position, orthogonal. Okay. So please remember, right, the properties of A dot B equal to 0. Okay. Then you have the other two. You can look at it by your own. Okay. Next, we have a cross product. Okay, so for a cross product, we're going to discuss further in the next video. Right? Thank you.